Okay, so this is all about just graphing transformations, how there are changes, and then you'll be working on, obviously, the homework online here. So let's look at some of the homework problems. And let's start with number 6. It says label each of the following functions g of x as a vertical stretch or vertical compression of the parent function until whether it's reflected about the x-axis. Okay, so I'm going to look at it just graphically or using the equation, but again, you can look at the graph itself, graph it on your calculator, the two, and compare them. So here's the original. What's happened? We've multiplied it by a number bigger than 1. So sorry about the bell. A number bigger than 1. So that's a stretch, 1.2. That's a vertical stretch. If that number were a fraction or decimal less than 1, then that would be a vertical compression. You push it down, okay? Multiply by negative, that is a reflection. So it's a vertical stretch with a reflection. Okay, this one says find the y-intercept for each of the functions g of x from exercises 5 through 8. Okay, so this is the same function we just looked at. Okay, what is the y-intercept? The y-intercept is your 0 term, which is your a here, which is negative 1.2. That would be your y-intercept for this one. You can go back, think to a times b to the x. A is your y-intercept or 0 term. Okay, number 14, describe the translation. Okay, so this is a translation. That means we're adding or subtracting something. So here's f of x, here's g of x. What changed? We subtracted 2. That is not with the x. Okay, that is not with the x, so that means we moved down 2. If it were with the x, then that means it would have been actually in the exponent, minus 2. That's with the x, but this is not with the exponent. So when it's not with the x, remember we do our head up and down. It is what you think, so that means that moved it down 2 or translated it down 2 units. Okay. Next problem. 26, match the graph to the characteristic of the given function. Now, again, if you're having trouble just understanding the overall concept, one thing you can do is plug in values and just make up a function. So, for instance, like this particular one says a is less than 0. Okay, so that means what? It's a negative number of some sort. B is greater than 1. So what do? You come over here and you make up a function. A is less than 0. So like negative 2 times B is greater than 1. So 3 to the x. And then you put that graph or that function in your calculator and you graph it and you try to match it with one of these 4. Okay. Now, thinking in terms of the state test, this would probably be a good non-calculator question. Okay, so if I'm looking at this function, again, it's just made up, but it fits this criteria. That means my y-intercept, or my 0 term's negative. Again, sorry about the bell. Okay, so that's negative 2. So that means it's either this one or this one, because these y-intercepts are positive. Okay, now the other thing is, this is a 3. So if we ignored the negative here and thought about this, this is what our function would be doing. But because we multiply by our negative, again, because it must be going up because it's bigger than 1, we reflect this. Which one shows that reflection doing this? That would be this one right here. Okay, let's think about this one. A is greater than 0. That means my y-intercept is positive, so it's either this one or this one. B is a fraction less than 1. That means it's got to be decreasing. This is the one that's going down. So that one would match this one. A is greater than 0 again. That means it's bigger than 1, or a positive, sorry. And B is greater than 1, which means it's got to be going up. So that one is this one, which by default means that this is the only one left, okay? A is less than 0, that means it's a negative. And B is a fraction less than 1, okay? So usually that means it's going down, but when we do the negative, we flip that, which makes it do this right here.